Hello and welcome to the Halloween, the October 31st edition of the Cluster API sub-project meeting for SIG Cluster Lifecycle. We've got a nice agenda going today, so let's go ahead and dive right in. So first up is Siddharth with static IPs. We link to issue 519 here. Go ahead and pull that up. Can you give a little background? I don't know if everybody's up to speed on what the issue is. Let's see. Yes, Siddharth is here. Maybe I can't hear you if you're talking. Maybe the microphone is not working on your computer. All right, let's come back to that one while we get the things working. Hardik, you're next up with number 531.
Yes, so I had created PR on the machine phases quite some time back, and I guess I had also created the proposal doc, and then I had created the PR, and I don't see much movement going on there now. Just wondering if there is a consensus. If people are okay, then maybe we can merge it. Just wanted to bring it up on the table. That's
all. So it's like David gave it an LGTM. I don't know how many other folks have had a chance to look over it. Jason, looks like you've looked at it. I guess first, the main question is, anybody have any concerns? Again, the API is an alpha. We can always merge things and undo them later if we figure out that there's a different way we'd like to do them. But unless we have sort of a better proposal, I don't see a reason not to go forward with this one for now. Thoughts?
Yeah, I think Alvaro from Ludza had vetted it pretty heavily, and I think there is some justification. David commented on it. I think that it's definitely there to have something that represents the specific life cycle of the machine, not just having the NodeRef, especially for UX purposes. So I would love to see it come in.
Okay. I think what I'll do, I'll ping the PR again today, and we'll maybe hold it for 24 hours just to make sure nobody objects, and then we'll go ahead and merge it tomorrow, assuming nobody objects on the PR. I think, mechanically it's API changes, so there's not like complicated code to review. So it's more, do we want those API changes? And I think the answer is yes for now, and if there's something better, we'll change it later. Excellent. Siddharth, is your microphone working?
Thanks.
Sorry, Siddharth, is your microphone working yet?
Yes, can you guys hear me?
Yes, much better.
Okay, thank you. All right. So the issue that I wanted to bring about is the support for static IP for the machines. So this use case specifically, at least from the vSphere perspective, is quite relevant, primarily because in not all vSphere environment people might have DHCP running. Therefore, there is a need for allocating static IPs to the machines. So in theory, I mean, for example, for the vSphere provider implementation, what we have done is we've already enhanced our spec, like our provider spec for the machines, to actually include the provision for static IP. However, there's a one big gap that needs to be addressed. Essentially, if we were to use any of the higher level abstractions, like a machine set or a machine deployment, which deals in groups of machines, then we need a way to do some basic IPAM kind of stuff. So essentially, a construct something like an IP pool is something that we probably want to introduce somewhere in the system, so that, for example, if someone does a machine set wherein they say, I want 5 of these machines, and if the machine somehow can indicate that, okay, please use this particular, let's say, the IP pool for allocating the IPs, then the cluster API controllers should be able to allocate a unique IP in a static, and allocate it as a static IP, set it as a static IP for the machine definition, so that then when the actual VM is being rendered on the particular cloud, then that static IP could be pushed in. Now we're kind of missing, there is no concept of IP pools at the moment. I posted this question on Slack, and one interesting use case that came along was, maybe bare metal support later on might also need something like a static IP. Because most of the cloud providers right now, like AWS or GKE or OpenStack, they all handle that IP allocation automatically. And it doesn't matter if it's a DHCP server or not, they'll handle that underneath. So I just want to get an opinion from folks, like, do you guys see static IP as something that, cluster API as a whole should support, number one? And if you guys think that it's a good idea, then maybe, any ideas around how do we want to implement the static IP, like IP pools? As I was talking to one more, I'm sorry if I mispronounce your name. One suggestion was maybe we can implement some sort of like a mutating webhook, admission webhook for the machines object, and implement some sort of a controller there that could do this unique job of tying the IPs from the IP pool and allocating to the machine object itself right at the time when they're created. And therefore, from the provider actuator code, like the machine actuator code, they just get the machine object filled with the IP, so they don't have to really do any custom logic, but just operate as if they would have done otherwise. That was essentially the very high-level proposal and questions. I'm open to what sort of comments or thoughts others have on this. I'll mute myself now.
So Samsung has an SSH provider, which also depends on static IPs. In our current use cases, the static IPs are part of the provider spec. And since we're dealing with bare metal, we actually don't have a use case immediately for the machine set controller. But we have looked at extending our use case to arbitrary VMs, in which case it might be possible to use the machine set controller. I think so. So the first part is, I think there is a use case for allowing the machine set controller to work with machines with static IPs. And then the question of implementation, the mutating webhook is interesting. Another idea that we had thought about is to have in the cluster object, you can have, as part of your provider spec, the IP address information or IP address ranges. And then right now, the machine set controller creates machines, but they don't have IP addresses. And that's fine as long as your machine controller understands how to assign an IP address from the IPs which are stored in the cluster provider spec. So maybe this is an idea I should write down in detail on this ticket. I think there's a need. I'm not sure what the solution is. I'll with myself now.
Right. So actually, in fact, like the proposal that you said, right, wherein if we enhance the cluster object or the cluster definition itself to incorporate that IP pool information and then utilize that. I mean, that's roughly the way internally I was actually thinking and was trying to do a POC around that with the vSphere provider to basically enhance the cluster object with some sort of an IP pool information, and then pretty much what you just said. So yeah, but the only thing is now what happens is now the machines. So either the machine actuator now has to do that job of making sure that it pulls out an IP, allocates it at the runtime, and then the only complication is if they're like someone is creating like ton of machines in parallel, there's a little bit of synchronization issue that we have to kind of make sure that we don't run into allocating the same IP to two machines, given if there are multiple getting. So that's where, I mean, essentially the initial suggestion around maybe if we can implement the logic in the mutating admission webhook, then that at that place at least, then probably a slightly better place to solve that problem. It's not essentially, it doesn't really solve the uniqueness problem, and you still have to do the synchronization part, but probably a slightly better location to solve that. But yeah, that's all I wanted to add.
So I'll throw out a couple of things. One is, Siddharth, you mentioned at the beginning, that this isn't really needed on public clouds because they do IP address allocation automatically. And while that's true by default, I know at least on GCE that when you create machines, you can create them with specific IPs. I think you have to provision the IPs ahead of time, but I mean, you could, if you really wanted to, provision a bunch of IPs, and then when you create machines, put those things together and assign them. So I think you could shoehorn this into at least some cloud environments if you really wanted to know which IPs run which machines. The other thing I'll say is it sounds like we have at least 2 providers that would sort of be implementing the same thing here in parallel in their provider configs. And I think what we're looking for when we're trying to figure out what to put into the sort of the generic the APIs is things that would be useful across multiple providers. So once we hit sort of 2, then it becomes interesting to start talking about is this something that we'd want to standardize, right? And even if it doesn't apply to all environments, right, they can be optional fields and we can just leave them blank and let the clouds do their default thing. But especially I think if we can show that there are cases where in the clouds you also might want to do this, then it becomes something general that we could apply across all environments optionally, and it might be required for some bare metal environments. But even it sounds like with the vSphere environments you're talking about, it's not always required. It's sort of an optional thing. Like in some cases you'd need the IP address management, and in some cases you wouldn't, right?
Yeah, that's absolutely correct. I mean, essentially, I can actually make a case for even the OpenStack provider, because in OpenStack, again, you can allocate a neutron port ahead of time and do pretty much the same thing as you mentioned earlier. So yeah, I mean, that use case probably is applicable for more than just vSphere, but I think not as widely used though. So.
Yeah, I was just going to say that this is definitely something that's applicable to OpenStack. One of the ways that we've looked at doing this, because having it directly in the machine controller might be a little bit difficult, and doesn't necessarily make a lot of sense because it tends to be fairly stateless, was we were looking at implementing specifically a separate controller that dealt with IPAM, had specific domain-specific CRDs that could represent things like IP pools, private pools, public pools, etc. So that's something that we are looking at implementing as well. So maybe we should pool together on something like that. I don't necessarily know if it makes the most sense to put that directly into Cluster API, because I think it has more general applicability, but it's definitely something that we should address.
Yeah, that's a great point, Jason, is if we do see some consistency here, does it make sense to put it in the cluster in the machines, or does it make sense to just create a different CRD that is IP pools, right?
Okay, so it seems like, I mean, there is a common interest, seems like, in this particular area. So, I mean, if it's okay, I mean, what I can try and do is I can maybe start a Google Doc and share with everyone where at least I can spec out things that at least I've thought about and what we've just heard from like few other folks. And maybe we can collaborate on then one document and one proposal, and then, refine the ideas and see which direction from the implementation point of view we want to go for this particular piece. Does that sound okay? I mean, unless somebody already has started some document, or then I'm more than happy to kind of collaborate on something else. But if not, I can create one.
I haven't seen a document going around, so go for it.
Okay. I'll probably try and put together, and maybe for the next meeting, I'll try and create something and share by then. Thank you.
And one more thing, Siddharth, I don't know if you're reading the chat, but Justin put a note in chat that it's potentially also useful on GCP, where we use static IPs for masters as well. So even on clouds, there are cases where you want to bind specific IPs to specific machines. So definitely, you should cover that too. All right, David,
just
gitbook.
Okay, so first I want to thank everybody who reviewed it. In particular, Mathis corrected so many errors. I created an umbrella ticket this morning with some of the things that I think are necessary, and then some of the things that I'd really like to see, hopefully before like KubeCon, but it's not contingent on KubeCon. It's just there's certain guidance I think that we don't have enough specificity around. Things like how do you determine if a node is provisioned or not? And these are questions that have been ongoing for months, right? So they're not going to be resolved soon. I wanted to see if we had enough consensus to go ahead and merge what we have now with the idea that we can then parallelize the documentation of the rest of the components. And then I have one sub issue on that. This is, I think, the one blocking issue right now is that we don't have an agreed upon way to serve these static web pages. And I've created a personal Firebase account. I've used that. I haven't shared it widely yet because I don't know what it costs. But it's also possible that we could use GitHub pages. And to me, the decision point there is sort of, A, do we value the Firebase analytics and advantages of using Firebase? Or do we think GitHub pages, which are free, are sufficient? And then B, to what extent is like a gitbook? So one of the things I did for this is to make the gitbook reference the code, I added Doxygen markers to our API types. I don't know if there's interest in upstreaming that type of work to KubeBuilder, but I mention it because one of the reasons we were using Firebase is because KubeBuilder does. And I think there is value in trying to stay as consistent or depend on KubeBuilder to the extent possible.
So Jason, you put a note in chat saying that the Kubernetes docs use Netlify.
Yeah, so they're using Netlify as kind of like a CDN and static website storage. I don't know if there's any type of integrations between Gitbook and Netlify that would allow us to potentially piggyback on that.
I could look into that. So do we want to come to a decision on how this is served before we merge? I feel like it's less useful if it's not served. On the other hand, it's primarily a developer tool, and there are instructions for how a developer can view it locally. So we could decide to merge it without determining how we serve it.
Is there any reason not to use GitHub pages?
Probably not. I've used GitHub pages in the past, and I've found the process cumbersome, but no more cumbersome than Firebase. And someone's already tested this on GitHub pages, and it seems what they did was easier than what I did. So maybe it's easy. Does that not answer your question, Tim?
I just think it's a low risk, easy path to get the out serving to the broader community. So
okay, I could make that change today. That's quick.
I think someone mentioned last time that there might be some difficulties serving with GitHub pages, using branches and pushing to branches and so forth. If it's not difficult, it seems like a nice, clean solution.
So that's the problem I had in the past is that so the way that you avoid all of the Jekyll is you have to have a GitHub pages branch. And then the way that I did it in the past is I had a makefile target, which would change branches, build the changes, commit the changes, push them, and then check out change back. And so that's sort of fragile because if anything fails, then that target, you end up with a messed up repo and you have to clean it up. That said, you also have a similar conundrum when you use Firebase, because it also generates a bunch of files which may or may not be correct, and then you have to then untangle what's been done. So I'm not sure which is easier, but both of them are they're not trivial. Like, it's trivial for me to make it work with GitHub Pages or Firebase. What's not clear is if it will be long-term, if we'll like the solution long-term.
How hard is it to fix? Can we just use GitHub Pages for now and say if we don't like it, we'll change?
Yeah, I think it's like an hour's worth of work.
Okay, maybe we should just do that to unblock ourselves, and so we're not trying to run on top of your personal account and figure out how much that costs, and just get it in. Because I think I agree, running it locally is fine, but having it serving is significantly better.
Okay, I'll do that.
All right, you're up again next too. Question about NodeRefs.
Yeah. So I guess I don't have a concrete, I have a PR that I opened about this a while ago. And I haven't had any time to work on it. So really this is, I have two questions. The first is, how common is it for people to have manager and managed clusters versus having, and if this distinction is unclear, I can explain, but in the one case, you can have a cluster where all of the cluster API resources exist within the cluster itself. And in the other case, you can have a manager cluster that contains cluster API resources or external remote clusters. So the first question is, how common is the manager-managed case? Am I the only one that does it? I know Gartner does something like it.
I think it's way too nascent of a project. We haven't even cut the alpha 1 in full respect, right? So I think once we actually do that and get much broader adoption in the ecosystem, we will see a 100 flowers bloom, and then you'll probably see the common patterns emerge.
I think David's more asking, like, for the people on the call that are trying to implement this, are they trying to implement it inside of a cluster or in a separate cluster managing a cluster, right? So I agree that once people are actually using it in the wild, we'll see more people using it, but those people will likely be using the tools that are built by folks that are sort of here now, building up the patterns that people will end up using.
Right, and so the immediate problem that I have is that we increasingly depend on NodeRef, which I think is the correct way to obtain state about the Kubernetes nodes. But for the remote cluster case, we don't have NodeRefs, which means that we just right now cannot use machine sets, period.
Wasn't that one of the purposes of the PR that Hardik sent of copying conditions from the nodes into the machines was so that you could have the machine set not depend upon the node object at all, and the machine was the only thing that would have to try to bridge the two?
Hardik, does that work on a remote cluster? I mean, I think so. That could be made to work. That's sort of the point of the PR, is that I believe that the way those conditions are copied now is you reference the NodeRef. But when you lack the NodeRef, oh no, that's not okay.
Sorry, you mean the machine controller copies it when it has the NodeRef. The machine set controller doesn't depend upon the node anymore, or shouldn't
right.
Need to, right?
Right. I mean the machine. So the controller. What I mean is that the machine controller copies the node conditions, and it can only do that if there's a NodeRef.
I see. Right.
And so for the SSH provider that we have, there's a bunch of cases where we have this problem, and what we end up doing, we would like to fix. But what it is now is we SSH to the remote node, right? A better way would be to perhaps use like a cluster registry so that you can obtain an endpoint for the remote cluster and then connect to its Kubernetes API server and access those nodes directly. There may be other ideas.
Okay, so just one comment. So for the first part, how common the pattern is? So yes, at Gartner we pretty much do that way. So we basically have a manager cluster, if I got the analogy correct. So we basically have one cluster which controls not the other one, but many clusters. So basically, the control plane of those other worker clusters are hosted on this one big cluster, and then that one big cluster, you would see all the cluster API stack, machine API stack will be loaded there, right? And for the second part, the node reference part. So yes, so what we tried to make by design is that the machine set only needs to worry about the machine objects and doesn't really go till the node object via the node reference in between. And though at the moment it does not have a direct, so we didn't have this thing in the mind that we wanted to run the machine controller completely in the different environment maybe, and that's why the node conditions will be useful to machine set, or machine set might not have direct access to the remote cluster in general. But the idea overall was only from the design perspective that if machine set relies only on the machine, then we can avoid certain race conditions and so on. So this then applies to the higher level controllers as well. For example, the cluster API controller would only depend on the machine deployment and not worry about any other objects or controllers, and machine set only machine deployment relies only machine set objects and so on, right? So that was the overall idea. And for the last comment, for the SSH part, so we in general have completely avoided doing the SSH into the machines for multiple reasons. So one of the biggest reason I can put is that many times we want to run our worker machines in a private network, and when we do that, if you want to do the SSH and stuff like that, then we have to go via the bastion machine in between, and that becomes pretty messy. So we mostly tried to figure out a way using the cloud init scripts. So you basically basically what you want to run on the machine. You know how to bootstrap the kubelet. You know how to bootstrap the Docker and whatever certificates and all those things are needed. So from the machine controller stack itself, you can always feed in this cloud init into the machine, basically replacing certain parameters here and there. So that's the overall idea there. So we never SSH into the machine for any of the reasons.
So I agree with the concerns around SSH. And I see how using cloud init would allow you to extract, at least initially, what parameters are. But how do you, on an ongoing basis, update the node conditions?
So machine controller basically have access to the target cluster as such, right? So the machine controller knows that we call it the shoot cluster, or you can call it a target cluster. So machine controller has access to the API server kubeconfig of the target cluster. It can basically list down the node objects and then copy the corresponding node objects, node conditions into the machine conditions.
And so you do that in your actuators. So that's not part of the common. Is that part of the common machine controller, or is it an actuator?
Yes, so we have a slightly design difference there. So in our case, we don't call it actuator, but we call it driver. And that driver only has methods like create VM, delete VM, and list VM, right? So rest of the entire code base is considered or assumed to be shared code. So it's completely shared, and only the drivers have this pretty much information of create, delete, and so on. So to answer the question, who does the node condition copying part? So that is being done by the shared machine controller. And I just saw one comment going on the Slack, and I also pointed something there, which is about the out of tree drivers which you are right now working on. So because we had this kind of design, now what we are experimenting with is that we are just taking out the entire internal drivers, which has only create delete methods, and making them the gRPC servers, the way the CSI volume plugins are working. So we have a prototype for that, but I have certain other designs in mind, so I'm trying to implement that other designs with the gRPC server. So that's how overall in general it works. If it was understandable.
Okay, that helps. Thank you.
Just to give some feedback to you, David. So I know the Lutza folks also use the manager cluster pattern, and we are planning at Innovo on doing that as well. And I know that it's a relatively common pattern that's been used. Lutz has been using something like that for almost 3 years now. And the way that we handled it then And I don't know if this was ever actually in kubedeploy before it became cluster API, but we would use, because we had the kubeconfig very similar to what Gardener does, we could then access the API server, and we would, through that shared controller, then reference the nodes directly using the additional API server. So the parent cluster or manager cluster would then talk to the API server of the child cluster to get the information from the child nodes, as it were.
Okay, so I think the next steps for me then maybe to implement this locally for ourselves, and then we can have something to concrete to talk about whether or not we want to upstream.
So just to add on that, so if we are seeing this as a common pattern, I'll be more than happy to create a proposal doc on how the manager cluster stack could look like overall in general, and what could be pros and cons, and how will it be different from the way that we are doing the things. I can create a proposal on that if we see some agreement on that. Okay.
Great. Let's move on to the next, which is Jason's PR for phases support.
Yes, so this is just continuing on from the discussion we had last week. I updated the initial PR, which just adds an alpha subcommand, underneath that a phases subcommand, and right now it just implements create bootstrap cluster, just as a starting point for phases. And based on the feedback last week, I added the alpha subcommand to make sure that users realize there isn't, any type of guarantee around compatibility when using it.
It's a fairly short PR.
Yeah. When I started prototyping it out, I initially broke out more of the phases, and it's not until you get to the pivot cluster phase that it starts getting a little complicated, because we currently pivot in two different ways, depending on whether we're pivoting to the target cluster or from the target cluster. And I think as part of the phases support, it'll make sense to unify those approaches because they're mostly identical, except moving from the cluster is a little bit more comprehensive. So things are going to get a little hairier around that part. But the initial, create the bootstrap cluster and deploy the API server component, or deploy the cluster API components is very, very simple.
Awesome. I think I put this in a similar category to Hardik's earlier PR, where people should take a look over the next 24 hours. I think you had an LGTM, but it got removed when you pushed a change. I think the change was pretty small. So we'll maybe try to merge this in about a day as well, and let people have one last look. I think, Siddharth, were you about to say something?
Yes, so just I want to make a quick comment, or maybe ask a question to Jason about the pivot parts. I agree that, there are two phases of pivot, where you're pivoting from the bootstrap cluster to the target as well as the other way around. I mean, would it be beneficial to maybe have the CLI more as a generic model, this phase as a generic way, wherein you could actually add flags like, okay, from and to, and then maybe an additional flag of clearing out, clear the source. For example, you copy over from source cluster A to cluster B, move the things over, and do you want to clean up the resources from the source cluster where you're moving it from? I mean, because I think if you model it that way, then it would be very useful in general for other mechanisms as well. I mean, I think wherein, for example, if you were to create, for instance, the entire cluster not using, let's say, the kubectl, not using the cluster CTL, sorry, but at any point in time later in the lifecycle management perspective, if we ever want to do some sort of a pivot, then if we have a very well-defined, well-tested way of doing the pivot using, let's say, the cluster CTL with any generic way, so you can point it to kubeconfig 1, kubeconfig 2, and whether you want to clean up the resources on the other side or not, that would be really come in handy, I think. I don't know. That's sort of my thoughts were. I mean, maybe something like that could be done as part of this phase approach that Jason is doing.
Yeah, so that's exactly what I was thinking about with the pivot phase, doing exactly that, making a generic kind of alpha phase command that you can call to just pivot from any source cluster and any target cluster. One thing I did notice is that I think we actually have the potential for some race conditions right now as we pivot, because we're not actually necessarily taking care in both of the cases that we don't have two different kind of controllers acting on the same objects at the same time. And I was planning on trying to address that as well with the kind of genericized pivot as well, to where we actually kind of scale down the stateful sets that we're deploying, prior to actually pivoting the resources between the source and target clusters as well.
On that point, I have a quick question. Has anyone run multiple providers? I mean, like 2 providers which they did not both themselves implement on the same cluster?
So we do support multiple providers for the same. So we call it a seed cluster. So a single seed cluster can create clusters on two different providers. So we do have that kind of architecture, but generally we avoid that scenario for latency reasons. So we even try to make sure that the control plane and the real workers are in the same region, first of all. And that's even the first layer of, I would say, to prevent the long latency. Otherwise, the 2 different providers we do support, but we don't do it that often in general.
So I don't mean, just to clarify, I don't mean heterogeneous clusters that span clouds or anything like that. I mean, if I wanted to run the GCP provider and the AWS provider, I guess, so okay, I see. My question doesn't make sense right now because those are both local providers. Okay. It would only make sense in the case where you have managed clusters and manager clusters, right? Okay.
Yes. So what I meant was, for manager cluster, then it's more preferred to have a manager cluster in the same cloud provider, and even the better one is in the same region, because your manager cluster has a control plane of your worker cluster, and it's better to keep them as near as possible rather than keeping them into different region or different cloud providers. So that's and we try to follow that as much as possible. And it's we do support that we have one manager cluster which can create clusters on other cloud providers, but we avoid it completely. We don't do that.
I see.
So Hardik, just to
Go ahead.
okay. So Hardik, just want to clarify. I mean, when you say that you do support, so are you talking about, for example, Gardener as a product, or are you talking about maybe the cluster API implementation that you might be running capable of doing that?
No. So in general, in the Gardener. So the cluster API support at the moment is only in the MCM part, which is the machine API aspect. So we will have machine cluster API support for the Gardener, but I was talking only from the Gardener perspective at the moment, if that's the general question.
Okay, thanks.
So
I mean,
I was going to say, with the current design right now, what you would basically have if you had 2 different controllers for 2 different providers, you would have one that would consistently error when it tries to decode the provider config for the other one. And then, so there would be, it would work, but it would be ugly because you would constantly see errors for, the objects that belong or that are managed by a different, provider right now.
So maybe would it be helpful if we, for example, add some sort of like a type field or some sort of annotation label, any sort of identifier essentially to, let's say, the cluster objects and the relevant objects that could say, well, this cluster object, for example, belongs to, let's say, the AWS provider or the GCP provider or the vSphere provider. And that way the controllers, like pretty much the first thing that they check is, well, is it the type that I'm interested in? If not, then I don't even process it and only do it if it's of type that I want to serve. So that way, it's a small enhancement, but I think that will probably help support the case wherein if you have a centrally managed cluster and you want to run multiple providers to support this kind of thing, that the use case, because I think it's a valid use case. Incidentally, I've been thinking about the same use case in the last couple of days for some other reasons, but that's that's definitely, I think, especially in the case where you want to think about a managed, wherein you're just having a centrally managed one, does make a lot of sense.
Yeah, I definitely see, you see the same kind of thing come up with the ingress controllers, and basically they're just annotated to say, hey, I belong to this particular controller, and I certainly think that we could respect a similar pattern like that.
That sounds like something that we could potentially implement in the common controller as well, if we come up with a kind of convention around it.
It should just be first class to a field then, and not an annotation, because doing an annotation, which is like the double secret APIs, and if you're going to make that convention, then it should be first class.
I agree. I think we should probably make it just as a field type field in the cluster, or some sort of a provider type field in the cluster object itself, and any level object to say, what is the type of the provider, and that could be literally just an enum kind of a value which could map to all the possible known providers.
Well, I don't necessarily agree that it should be a strict enum there, because then we would have to track what the kind of known providers are, or we would have to implement it somehow within the custom providers. I think, as we're registering the actuators, we can pass in what the value that we expect is, and that could be used to compare against the field.
String.
Good point. Yeah.
Yep.
Are you envisioning that string being mandatory, or if it's blank and there's only one controller, that controller just sort of, like, is there a way to make like a default controller, or like let the controller know that it should take ones that aren't explicitly tagged? Because I think the common case is going to be running a single controller per cluster and not doing multiple, and it would be great not to have to set this field all the time.
Well, I think the problem with that is if we go with the current approach, two different providers would basically both be running kind of the same common controller right now.
Yeah, so I think what's interesting about that is that right now you'd have two providers. They'd both see a machine show up. They could both try to parse the provider config, and one of them would probably fail and not handle that machine. And the other would succeed and say, oh, I understand this provider config, I should be managing that machine. So we sort of have that implicit already, and the string would basically just be a shortcut to say, don't even try to parse the provider config. But you can sort of already get that signal implicitly if you really want to.
In addition to that, maybe, when that controller is able to parse a particular, let's say, the machine definition, and if, let's say, the type is missing, one of the other things that maybe the actuator can do is go back and retroactively basically mark that cluster or all the objects with the type that it has now known. So now then it's like that failure will happen only in the very beginning, and then the moment one of the provider understands that spec, then it will basically annotate, and then it's not going to bother the other providers anymore after that.
Well, if we handle it that way, then we can just probably define a custom error that we throw up, just like the kind of requeue error that we have defined now.
Yeah, that's true.
Yeah, is there like a human-centric reason to put a field in there, or is it mostly just for controller coordination?
I would think it would be mainly for the controller coordination.
Yeah, I guess I'm wondering how far we can get with the provider configs, because provider configs are already structured data types, and the controller should understand how to handle specific types of those, right? So you could imagine having two machine controllers, one that understands v1 alpha 1 and one that understands v1 alpha 2, right? And if it sees the wrong one, it doesn't parse it, or it says, I don't understand that, I'm just going to skip handling that machine.
So the one question I have there is, how do we currently handle an undefined provider config right now? Because I think right now you can define something without specifying the provider config. So if we do go that approach, we would probably have to make the provider config mandatory at that point.
I think right now, if you create a machine without a provider config, the machine controller will error out, right? It'll call the actuator, and the actuator won't be able to create a machine. It might be useful to have the machine controller itself just say, like, that it doesn't know what to do with it. I mean, you could also imagine having an actuator that doesn't need a provider config and just has a whole bunch of default settings passed on the command line, and it just does its thing, right?
Yeah, that's the one case where I can see a separate field would be beneficial to differentiate.
One other additional question that I have is, I mean, I know in the past we've talked about variants within a provider. I just want to kind of bring that up here as well in the context to say, you know, if and when we start supporting different variants within a provider, how do we want to handle that? Because that technically, I mean, I'm still not very sure like how that multiple variants would work. Like, is that like the single controller that is running now that is capable of serving all the variants on the fly? And if that's the case, I mean, for example, for the purposes of this provider identification, I mean, if it's a single controller, then probably it's okay. But if it is, let's say, if you were to explicitly run different controllers for the same provider to serve different variants, then you might want to, then for this identification purposes, then you probably want to identify both the basic provider plus the variant that it's serving. I mean, again, I don't know. Again, have we made some decisions or some more concrete decisions around like how we plan to support variants? It kind of goes into a different direction of questioning, but something that I don't know the answer to. If anybody has, please.
So my initial thoughts with the AWS provider was to basically try to decode into the separate provider configs for each variant. And if I could decode one of them, then that would determine which kind of variant to proceed from there. But having, you know, fields that I can key off of would be kind of a much cleaner approach there as well.
So would it be fair to say that, I mean, the way we are envisioning different variants support within a provider is you still have just the one single provider controller that is running, and that should be capable of, based on the spec, that should be capable of rendering, you know, the infrastructure based on the variant that has been supported or that's been chosen in the spec, like a field maybe within the provider spec or something.
That's the current approach that we've talked about for the AWS provider, but we really, you know, we're still at high level discussions around that. We haven't even, you know, really fleshed out a full spec yet. Has anybody else looked at variant support yet?
Nope.
Some of these fields that we're bringing up almost sound like meta fields for provider config, where variant and the name of the provider are all meta types.
Yeah, that's a good way to think about it, right? It's basically, here's some information about the provider config that you can look at if you want to before trying to parse it.
Yep.
We have 5 minutes left, and there's one more thing on the agenda, so I'm going to have to table the rest of this discussion to make sure we get to the last thing, which is that there's a PR about adding a provider ID. And it looks like it's related to the cluster autoscaler, and I wanted, hopefully, Vikas is on the line, because I wanted to hear some more background about exactly what this would be used for and how, because I'm very curious, and I didn't quite get enough information out of your pull request comment.
Yeah, so hello everyone, I'm Vikas from Red Hat, and we have been working on a POC with the cluster API as an out-of-tree provider in the autoscaler. So there is a logic in autoscaler where it gets the provider view of the machines and get the nodes from kubelet nodes, and then compares to find out like which machines are not registered yet within a period of time. And then autoscaler triggers the delete of those machines. So for this logic, because cluster API code is generic and it doesn't have code specific to any one particular provider. So there at that point we felt this need that we need a provider ID in the machine status, so that when cluster API implementation of the nodes function returns the list of the nodes, list of the provider IDs, it can compare with the list of the nodes from the Kubernetes side, and then it can, based on that, it can compare and figure out which nodes are unregistered nodes. So that's where we felt that provider ID field should be added in the machine status. And actuators should be setting this provider ID field once the machine has been realized by the actuator.
So it sounds like there's a requirement for this provider ID field to match the provider ID that's reported by the kubelet. Is that true?
Yes, that's true. And because cluster API provider has a generic code, so this has to be set by actuator, because actuator only has the specific logic.
I think if we have this expectation that it must match what's in the kubelet, we should add that as a comment to the field.
So sorry, I could not hear that. Can you please come again?
Sorry, I think if we have the expectation that this must match what's in the kubelet or in the node object, we should add this as a comment to the field. Can you hear me now?
Okay. Yeah. I'll add that comment in there.
Okay, so 2 cents from me, because I have in past worked on the autoscaler integration with the MCM. So first of all, the vanilla autoscaler have, right, at the moment in the community, that would work anyway. You don't really, if you're not making the core logic of the autoscaler aware of the machine API stack, it can just look at the node objects and do stuff. It will still work, but adding the provider ID, I will very much support adding the provider ID in the machine object, mainly for a reason that if you look at the provider ID, it's pretty informative in my opinion. You see, for AWS, for example, it tells you which region, which zone, what is the instance ID. For Azure, it will tell you which subscription you are in. It gives you a complete detail. It uniquely identifies a VM on your cloud provider, probably. If you're on your OpenStack, it will tell you the same kind of details for the OpenStack. So we had, even without thinking about the stronger use cases, we had added the provider ID in our machine object just to map it to the right VM exactly without guessing that which VM could it be via IPs and whatnot, right? So I would very much support adding the provider ID in machine object. It could be in machine status or where that can be discussed. But
yeah, it makes more sense in the machine status, because that will get added after the machine has been realized, after the machine has got provision. So that's why it will make more sense to have it in status.
Right.
Oh, sorry. Go ahead, David.
We have a generic problem, and this is one of the open documentation issues, is how do you determine when a node has been provisioned, right? We have, the actuator has something called exist, but we don't give guidance on what existence means. And there's no field in status for arbitrary consumers to determine when a machine's provisioned. So
I think there is, because that's what the NodeRef is for, isn't it?
right.
So that's where, for example, in autoscaler, it waits for by default 15 minutes to see if the machine has got reflected in the nodes list, kubelet nodes. And if after that time, still after that time, it's not, machine is not, it doesn't reflect in the Kubernetes nodes, then it is considered as not provisioned, and then machine object is triggered to be deleted.
So maybe I'm missing something, but if it's the responsibility of the provider to do all of the actuation with the cloud provider itself for creating, destroying nodes, why does a third party need to have some kind of unique identifier for the machine beyond the machine CRD itself? I mean, the machine CRD distinctly represents a machine.
Yeah, because machine has to link with a kubelet node object, Kubernetes node object. Machine has to ultimately become a Kubernetes node. So if machine is not able to become a Kubernetes node after a certain amount of time, that means there is some problem in that machine. And for example, higher level entity like autoscaler need to take some corrective action at that time. Like, for example, like by default, after 15 minutes, if machine is there, provider is saying that machine is there, but that machine is not there in the Kubernetes nodes, that means there is some problem on the machine. So then it takes that action to delete that machine. So that's why that this linkage is required, to have a provider view of the machines and to have a Kubernetes view of the nodes, and then compare.
So if the machine sets actually had that support natively, where the machines would actually have some version of health to verify that they're actually healthy, then that would kind of eliminate that need for the cluster autoscaler to need that external test, wouldn't it?
I don't think so, because machine, what is the parameter to say that machine is healthy? Like, machine has to, from the Kubernetes point of view, that should get registered as a node.
Yeah.
So, right, but this is a problem that we have generically right now, because if you're using machine deployments or machine sets, you would want kind of a node that never actually kind of came online, or a node that becomes unhealthy to eventually be removed and kind of brought back online as well. So it seems like a generic problem that we have to solve for the machine set and machine deployment.
Yeah. So health can be health or healthy or unhealthy thing can be seen at multiple levels, like at the provider level, at the machine level, and also at a higher level where we have to see it whether it's healthy to be called as a Kubernetes node.
Yes, but we already have that with the NodeRef. So we know that if the NodeRef is set and the node says it is ready, we are aware that the node is joined to the cluster and is ready to accept workloads. if the NodeRef is set and the node is not ready, we know that there's a problem. We can identify that through the node and discover why it's not ready. If we don't have a NodeRef and we continue to not have a NodeRef, then we know that the node hasn't been successfully provisioned because it hasn't joined the cluster and hasn't been updated. So we already have the primitives there to be able to identify, does this node exist, etc. And I think one of the overall goals in the long run, but in the long run, is to enable the autoscaler to have zero awareness of any cloud provider whatsoever, because we just leverage the API that cluster API provides. And so having some kind of, we already have the mechanisms to be able to do that without adding some kind of provider identity.
So the problem here is that we don't want to break the existing entry providers in the autoscaler. So if we want to use NodeRef to determine that whether a machine has become Kubernetes node or not, the same logic is not applied by other entry providers in the autoscaler, like AWS provider or GCE provider. So, and there is an interface which has to be implemented by a cluster API provider also. So if we don't want to break the existing providers which are there in autoscaler, we'll have to implement it in the same way. Otherwise, if we try to leverage NodeRef, then we will end up breaking the existing providers. I think that's what we don't want. Like, we want to have cluster API also there and entry providers also working at the same time, and then eventually remove the entry providers. That's how we want to go. So to have that happen, I think that's why we need this provider. And we can continue discussion on the PR also. Like, just to trigger the discussion, I added the link in the agenda.
Yeah, thanks for doing so. I didn't realize this would take quite so long. We're a few minutes over. Let's continue discussion on the PR, and if we haven't reached a resolution, maybe we can continue next Wednesday as well. So I think this is a very interesting topic. I understand your point and Hardik's point about the provider ID being super useful, but Jason also has a really good point of, if you expose that sort of information, then higher level controllers can and will start to depend upon it. And is that really something we want? So let's continue offline, and then maybe circle back next week and continue in person as well.
Thank you.
To be respectful of everyone's time, we're going to call it here. And thanks again for coming, and we'll see you guys soon. Take care.